Hi, I'm Gobinath Tamilwanan, Product Marketing Manager for SMUs at KEYSIGHT Technologies. I'm sure you've heard about the global semiconductor chip shortage. It's been all over the news for months as a reminder of how many everyday things we use, from PCs to smartphones and cars, depend on semiconductor devices to work. As a result, you need to reconsider your designs or redesign products to work around the shortage. With millions of elemental components such as transistors and diodes, any such reconsiderations or redesigns becomes a burdening task demanding thorough, reliable, and fast tests. Component-level IV characterization tests require you to perform current versus voltage measurements to help you understand your device's behavior. A test device is characterized through IV measurements, and key parameters are extracted from their IV curve. It is an important step for device development, quality assurance, and device modeling. Let's talk about how to perform IV measurements for low power ICs. First, you need to measure the current while sourcing the voltage at the same time to draw the IV curve. Synchronization of the source and measure is important to ensure you capture device behaviors according to the specific changes in input. A big portion of your device's datasheet and specifications will utilize this data. Second, you need to perform measurements at various positive and negative bias conditions, while covering the wide dynamic range for the current changing from sub-picoamperes at off state to above milliamperes at on state. This is necessary as low power ICs have bipolar characteristics, and you need to measure the wide range of characteristics while sweeping and stepping through the bias conditions. There could even be cases where you need to perform multiple pre-measurements at the same bias condition to find the optimal range. Then, perform the measurement at the optimal range for that identified bias point. Third, you must measure the ultra-low current for accurate leak current evaluation. For low power ICs, the measurement needs to go down to the femtoamperes range in the sub-threshold region. Fourth, you will have to synchronize the measurement at each device terminal. For example, for a basic transistor measurement, you need at least 4 SMU channels to characterize the device. The drain voltage and the gate voltage need to be swept multiple times in a synchronized manner to obtain the right device performance data. And lastly, you need to prevent inadvertent device damage from excessive voltage or current. Low power ICs are generally a high gain active device. When measuring new devices with unknown characteristics, the drain current can drastically increase more than expected by the change of the gate bias condition. Compliance limits need to be set accordingly to prevent this from happening. As you can see, there are many test challenges to consider when testing low power ICs. Now, let's talk about the equipment you need to help you test as quickly and easily as possible. As devices, modules, and integrated circuits become more highly integrated, the number of ports to perform characterization on them increases dramatically. More ports require more DC and dynamic measurement diversity, more precision power supply channels, and more instrumentation such as pulses and digitizers. But simply adding dozens of channels and more equipment is not a scalable solution for your benchtop, especially with the limited space on your test bench or rack. You need to reduce your footprint and the overall cost of test. Device complexity further pushes you to test at a higher accuracy and speed due to the static and dynamic characteristics of low power ICs operating under lower power consumption. Basic test instruments are simply not precise and fast enough to characterize low power circuits that operates among multiple states such as sleep and active. And as if these challenges were not enough, you need to perform and synchronize measurements across all test terminals concurrently while preventing device damage during testing. This demands sophisticated test automation software and complex synchronization among multiple test instruments. To address these challenges, you need a high channel density source measure unit or SMU. An SMU is the instrument of choice for IV characterization of low power ICs measurement challenges because it integrates voltage and current sourcing as well as voltage and current measurement capability in a single instrument. It looks like a power supply, but it supports 2-quadrant and 4-quadrant operations for semiconductor bipolar characteristics. SMUs also support wide dynamic range with multiple ranges and auto-ranging, ultra-low current measurement capability, precise output control through the feedback loop, and many more application-specific measurement needs. For decades, KEYSIGHT continuously enabled innovators to push the boundaries of engineering by quickly solving design, test, and validation challenges. Our SMU portfolio is no exception, and it helps you get quality products out to the market in a timely manner. And we give engineers options to choose what's best for your use case. Today, we are excited to introduce to you the latest advancement in precision SMU technology from KEYSIGHT, the PZ2100 High Channel Density Precision SMU solution.
Introducing the all-new PZ2100 series, a high-channel density precision source measure solution that packs all your SMU needs within a 1U rack space, 5 times better than SMUs of equivalent performance on the market. Address a variety of applications across multiple industries with one or a combination of high-resolution SMU with 10 femtoamperes resolution, high-speed SMUs with 10 microsecond narrow pulse and up to 15 megasamples per second sampling rate, high-channel density SMUs with 5 channels, providing a total of 20 SMU channels within a 1U rack space. Protect your test system from obsolescence, cut down your cost per channel, and save valuable rack space by adding multiple mainframes for a higher SMU channel count, with no needs for cooling spacers. Gain ultimate flexibility and scalability with any combination of SMU modules as needed. The integrated pulsar and digitizer supports DC to wide dynamic measurements, eliminating the need for additional test instruments. Focus more on characterization and less on system bring-up tasks with simple channel stacking and synchronization with zero programming. Accelerate your test with flexible control options using the graphical user interface, Pathwave IV curve measurement software, or through skipping programming via LAN, USB, and GPIB. Pack all your SMU needs within a 1U rack space and save valuable time and effort with the PZ2100 SMU solution. For more details, visit keysight.com/find/PZ2100.
If you want to address your growing footprint challenges, the PZ2100 SMU solution is what you need. With 5 times higher channel density than any SMUs of equivalent form factor on the market, an integrated digitizer, multiple configurable SMU module options, and easy scalability, you can save your valuable rack or test bench space, even with the growing channel density requirements for your component IV characterization needs. If you want to address your increasing accuracy and measurement speed requirements, the PZ2100 SMU solution is what you need. With 15 times higher sampling rate on the market, you can confidently perform static to dynamic measurements for your low power IC characterization requirements, now and in the future. If you are an engineer who needs to address channel and instrument synchronization, the PZ2100 SMU solution is what you need. With zero programming needed to synchronize all 20 channels within the 1U form factor, eliminating redundant wiring and communication delays, quick test initiation with Pathwave IV curve measurement software, and easy adoption into various test environments, you can accelerate your test prototyping, debugging, and troubleshooting stages of your component IV characterization tests. Simply put, if you want to focus more on characterization and less on synchronization, the PZ2100 SMU solution is what you need. With this new addition to the KEYSIGHT SMU portfolio, you can address all of your SMU needs, whether you need an application-specific SMU, selection based on your form factor requirements, cost per channel, or even in terms of specifications and channel density. For other SMU needs, KEYSIGHT's existing SMU portfolio has you covered. Let me now introduce our SMU portfolio and discuss how to select the one that will address your specific use case. If you need advanced semiconductor device or material characterization beyond IV characteristics, we offer the B1500A Semiconductor Device Parameter Analyzer. It supports all aspects of parametric testing, from basic manual measurements to test automation across a wafer in conjunction with a semi-automatic wafer prober. Some application-specific examples include characterization, reliability, failure analysis, and on-wafer testing of advanced semiconductor devices and materials, such as components including transistors, diodes, ICs, image sensors, MEMS, solar cells, and optical. Memory devices such as DRAM and non-volatile memories, and materials such as carbon nanotubes, graphene, and organic semiconductors. The B1500A is a modular instrument supporting a variety of module types. Modularity is important because parametric testing continues to be an extremely dynamic area where you are constantly asked to do new types of testing, such as capacitance testing, high-speed testing, and fast-pulsed measurement. It supports auto-switching of DC to IV, CV, and fast-pulsed IV measurements with advanced pulsed IV and ultra-fast IV measurement capability integrated, along with more than 300 ready-to-use application tests. Next, if you develop power semiconductor devices, we have the B1505A Power Device Analyzer and Curve Tracer. Or if you are a power electronics engineer who designs circuits using power semiconductor devices, check out for the B1506A Power Device Analyzer and Curve Tracer for circuit design. They both support all aspects of power device evaluation, such as characterization, reliability, failure analysis, on-wafer testing, and thermal testing of silicon-based power devices such as MOSFETs, power diodes, and IGBTs or insulated gate bipolar transistors, as well as wide bandgap power devices such as gallium nitride, silicon carbide, and gallium oxide. The B1505A has several powerful features that provide dramatic usability improvements over traditional curve tracers. They allow you to save and display multiple data traces to easily compare them with data from the current measurements. They also allow you to graphically define forbidden regions in terms of voltage or current, such that the measurement immediately ceases if the trace enters the forbidden area, while keeping a running record of the most recent trace changes so that you can replay and save measurement trace data even if the device is inadvertently damaged or destroyed. The instrument supports both on-wafer and packaged device testing with automated IV, CV, and thermal test capability from -50 degrees Celsius to 220 degrees Celsius. The B1506A has many of the same capabilities as the B1505A, but it is focused on the needs of power semiconductor device users and circuit designers rather than on the needs of power device manufacturers. It has its own unique software interface, Easy Test Navigator, that provides an intuitive way to automatically generate a complete device datasheet, enabling engineers who are not test experts and whose only goal is to create a device datasheet to save valuable time and effort. If you perform evaluation of advanced material, semiconductor device, and component level testing on the bench for broad applications, we have the B2900B series precision source measure units. The B2900B SMU series is ideal to test semiconductor devices, discrete and passive components such as diodes, photodetectors, sensors, transistors, and ICs, precision electronics and green energy devices such as solar cells, power transistors, and battery, as well as for research and education on new materials such as carbon nanotubes, giant magnetoresistors, and organic devices. This SMU family has an integrated graphical user interface that supports measurement and graphing right from the front panel, and it is available in both 1 and 2 channel versions. It offers unmatched measurement throughput and supports the conventional SMU Skippy command set for easy test code migration. There are multiple instrument remote control options available, such as Pathwave Bench View, B2900B Graphical Web Interface, Pathwave IV Curve Measurement Software, and Easy Expert Group Plus. This multiple software control option allows you to choose the solution that best fits your particular SMU application. If you are an avid PXIe form factor user who has invested in a PXI chassis along with other types of instruments, or focused on creating automated test systems, the M9600A Precision PXIe modules are the right option for you. The M9600A PXIe SMU series addresses all the needs of automated test systems in R&D, validation, and manufacturing across application areas including data center, silicon photonics, quantum computing, RF power amplifiers and front-end modules, VCSEL or optical devices, and other general component level devices and circuits test. It can make precise measurements broadly from DC to pulsed down to 10 microsecond pulse width with the sampling rate of up to 15 megasamples per second. The M9600A also offers a wide dynamic range measurement capability with seamless current measurement ranging, best fit for different application-specific test requirements. All of this and more while providing increased test speed and synchronization thanks to the PCIe bus speed and embedded PC controller. We have the SMU solution for you. Choose the one that satisfies the test requirements for your device under test and application, independent of the form factor. Thank you for watching. For more information on other application-specific tests such as low power IC, low current LED, VCSEL sensor and module, narrow pulsed LIV, DC bias sourcing for optical receivers and modulators, data center applications, and more, check out the relevant resources available throughout this KEYSIGHT University course each month. Start here to solve your design, test, and validation challenges so that you can focus more on characterization and less on synchronization. For more information, visit keysight.com/find/PZ2100.